Texan Global School. Evaluation of algebraic expressions. The numerical value of an algebraic expression can be calculated by assigning a specific number to each variable. In this way, the value of each variable is substituted and the expression is reduced to a numeric value. Let's look at the first example. Given the following polynomial, evaluate if x is equal to 1 and y is equal to 2. We can directly substitute the values and perform the evaluation. However, it is advisable to always arrange the polynomials in descending order and then apply the desired algebraic processes. So we sort the variables alphabetically to then leave the polynomial in descending order as shown in the solution. Now we will substitute the given values, where x is equal to 1 and y is equal to 2. We will use grouping symbols to organize the substituted values. Once the values have been substituted in the polynomial, we will simplify the expression arithmetically. Let us remember that the solution of arithmetic expressions has a hierarchy of operations where exponents and roots are performed first, then products and quotients, and finally additions and subtractions. So, according to the hierarchy of operations in this case, we perform the exponents first. 1 squared result in 1. 2 cubed results 8 is multiplying the number 2 3 times. Once the exponents are performed, we go to the products and simplify to obtain the numerical value, where 5 times 1 times 2 gives us 10. 2 times 1 times 8 is 16 and 9 times 2 is 18. We must be cautious with the signs of each term. With this, by the hierarchy of operations, we end with additions and subtractions, obtaining 8 as a result of the evaluation. In this second example, we are also asked to evaluate a polynomial if a is equal to 1, b is equal to 2, and c is equal to -1. Likewise, we arrange in descending order from highest to lowest exponent in the first variable. Later we substitute the given values to evaluate the expression. We will use grouping symbols to organize the substituted values, which are highlighted in red. We simplify according to the hierarchy of operations, exponents first. Remember that raising a negative number to an odd exponent gives us a negative number as a result. On the contrary, if we raise a negative number to an even exponent, the result is positive. So we get that 1 raised to the 7th power is 1. 2 cubed gives us 8. 1 raised to the 5th power is 1. -1 cubed gives us -1 since it is an odd exponent, or we multiply -1 3 times, which gives us -1. Then 2 squared is 4 and -1 to the 8th power. Since it is an even power, it gives us +1. We then perform the products and simplify to obtain the numerical value of -49. Once again, we emphasize the importance of grouping signs and symbols such as parentheses or square brackets. We suggest avoiding skipping steps to ensure a correct resolution process. In this last example, we will also arrange the polynomial in descending order to facilitate the evaluation. We then substitute the given values to evaluate the expression if a is equal to 2, b is equal to 0, and c is equal to -1. We will also use grouping symbols to order the substituted values. We then simplify according to the hierarchy of operations. Exponents first. 2 to the 4th power is 16. -1 cubed is -1. 2 cubed is 8. This squared is 0. 2 squared is 4. 0 to the 4th power is 0. 0 squared is 0 and -1 cubed is -1. We then proceed to perform the products. However, in this particular case, we can see that 4 terms are multiplied by 0. Then, all those terms result in 0. We simplify the remaining term, giving -304 as the evaluation solution. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com